Hi everybody, welcome to part 6 of the Bravo project. Today we'll be building a new module which consists of A&B registers along with ALU. Since all of these modules are on the same PCB, I'll probably be soldering everything. However, we will be focusing on A&B registers and we will be testing those modules. So with that, let's have a look at the logic behind the circuit first, and then later we're going to be building and testing the modules. All right, so let's have a look at our A and B register circuits, which are essentially identical. Here we are using a pair of 74HC173 chips, which are quad D-type flip-flop chips. And basically how it works is that we are able to control these chips using some control signals, and we'll be able to store the data on our bus into our chips, and then of course we could put that data back on our bus or on our output lines, which goes directly to our ALU. So let's have a look at this chip and see how it works. So the chip has 4 input pins marked from D0 to D3 and 4 output pins Q0 to Q3. There are 2 pins here, pin number 1 and pin number 2, which are output enable pins. And essentially what they do is they are active low pins, so when we bring them low, they put the data that is on the chip into the output. Now, if you notice here, you see that those pins are both are grounded. That means that we are permanently outputting data, and the reason for that is we're actually controlling the output of data through a different chip, a transceiver that you see at the bottom of the circuit. So for these 2 chips, we always want the data to be output on our output lines. Therefore, we do not control those. We just tie them low permanently. Now, for the input lines, there are 2 pins also, pin number 9 and pin number 10, which we basically need to bring them low again. They are active low pins if we want to read the data from the bus. So let's say that we have data on the bus and we want to read it into the chip. We just bring those 2 pins low, and that's why these pins are actually tied together on both chips, and also both of them are going to our A-in signal. So A-in signal will be an active low signal, and whenever we bring it low, it's gonna read the data from the bus into our chip. Of course, in order to do that, we need also a clock signal. That's why we have pin 7 on both chips tied to clock. And I guess that's it about these chips. Now, if you look at the output of the chips, they are going 2 directions. So one direction will be to A lines, because we're talking about the A register here. And those A lines go directly to our ALU. And also they're going to our transceiver, which basically gives us a control over when the data needed to be put back on the bus. So I guess we talked about the 74HC245 in the previous videos. This is basically an 8-bit transceiver with a pin for the direction of the data. In this case, we have the direction from A side to B side, and that's why we are tying the pin number 1 to high. And other than that, we only have pin number 19, which, as you can see, is tied to our A out signal. So the whole circuit is quite simple. Essentially, if we want to read the data from bus into our A register, we bring the AI low, and that will be reading data from the bus and storing it in our A register. And whenever we need to output that data back onto the bus, we just bring the A out line low. So that's really all about the registers, quite simple. And if you have built the Ben Eater's 8-bit computer, it's basically identical to that circuit. Now the B register is also the same. Nothing changed here other than obviously we have the B lines here, and the data actually is going to our B lines in our ALU circuit. So with that, let's go ahead and test this module. Well, first we need to build it, and then we're gonna test it.
All right, so we built our module, and I guess it's ready for testing. Now, the only thing that I would like to mention before starting the test is that we have all the signals from A and B registers on our bus. So we have access to our A lines and B lines, and these are essentially the data lines that going from our A and B registers into our ALU. So having those signals here enables us to basically read and write in those lines if we needed to. So with that, let me just mount it to our Arduino Shield. And the Arduino Shield, as you may know from the previous videos, will be providing power and also will enable us to run our sketch on the build and basically read and write from different data pins. Also, it will provide clock and so on. So I'm also going to mount our LED board. I had a little change on the LED board compared to the previous version that you saw in the previous videos. I made a little modification. I've actually added a clock LED here, as you can see. So I thought it makes sense to have actually an LED for the clock signal, so that when we are pulsing the computer will be able to see it. So the rest is the same. Essentially, it's the same LED board. I just have a new clock LED in the new version of the PCB, and that's it. Let me just mount it to our build, and I guess we are ready to go. So the only thing that remains is just connect the power to it, and we are ready. So with that, let's have a look at the sketch first. I wrote a special sketch to test the A&B registers.
So here is the sketch for testing A&B registers. And as I mentioned in the previous videos, we have two sections in the sketch. The first section is like a general functions to reset the Arduino pins and kind of initialize our Arduino shield. And then the second part is the part that we are actually doing the testing on the A&B registers. So I'm calling some functions from the main setup function in our sketch. First, I'm just initializing our serial port, and then I'm going to reset all the pins through the functions that we talked about in the previous videos. And then I have two functions here, one for testing the A register and the other one for testing the B register. Now, we have some timers also. I guess we talked about those as well in the previous videos, that one of them is basically creating a short delay, and we're going to use that in between the control signals so that we could actually see the LEDs turning on and off. Otherwise, if you don't use a delay in between the signals, they're gonna happen so fast that we will not be able to see anything on the LED board. And of course, we have the delay time for the clock. This is basically the length of the clock. Now, in regard to testing the registers, here's what we're gonna do. We're gonna first put something on the bus. Then we're gonna read that value from the bus and save it into our register. After that, we are going to reset the bus or clear the bus from any value. And finally, we're going to put that value that we already saved in the register back to the bus. So if you think about it, this way we will be able to test basically all the operations of our register, including the data input, saving the data, and then data output. So let's see how it happens. So in the test register function here, as you can see, first I'm just printing the statement that I'm testing the A register. I have a for loop, and I'm going through that for loop and basically generating a value between 0 and 255s, right? So our registers are 8-bit registers, so these are all valid values for our register. Now, once we did that, we take that value and we write it to the bus. And I have a function for that at the bottom that I'm going to show it to you shortly. Then we create a delay for visualization. So then we're going to set register A with that value, meaning that we're going to put that value that is currently on the bus into a register. We're going to clear the bus, and finally we're going to output the content of the register back to the bus. So let's have a look at these functions, right? Write to the bus, and first step is basically a simple function at the bottom that set all the pins on our Arduino to output pins, because we are trying to write something to those pins, right? And then, we have a variable type of word, it's a mask bit, and then we go through every pin in our Arduino that are assigned to our bus, and we basically do an binary AND with the value. Let's say it's a value of 1, we do binary value with that, and then we shift our mask bit to the left by 1, and we're going to repeat the process until all the bits, one by one, are written to our bus. So essentially this way you are setting a value on the bus. Now, if you go back up there, then the next step will be to set the register. And set the register function here is quite simple. The only thing that it does, it just brings the AN line low. You know that AN is an active low signal. So if we bring it low, that means that we are ready to write the data which is on the bus into the register. But in order to do that, we need a pulse clock, and therefore we have a call to a function down there again, which is pulsing the clock. And then once that happened, the data will transfer from the bus into our register, essentially saved in our A register. And finally, we just revert that back. We set the A in to high. All right. So after that, if you look at it at this point, we actually have data on the bus, right? Because the first step, we wrote something on the bus, so that data is still there. So the next function is actually clearing the bus, meaning that it just removes any data on the bus, and that's, again, quite simple. Just like write to the bus function, we have a clear bus function, except that here we are setting a value of 0 on the bus, meaning that we're going to reset all the pins on the bus and set them all to value, and we expect that all LEDs will be off at this point. And once we did that, now the bus is clear, so we could actually run in the final step, which is output register A, meaning that we put the data, which is right now in A register, back to the bus. And if we visually see it, that actually data is coming back to the bus, that means that our register is working fine. However, in this step, we are also printing that data on the screen in our terminal. So let me show you the output register A function. Output register A, as you can see, bring the A out signal low. Again, that's an active low signal. And then read the content of the bus. And that's a function again here, read from the bus, which goes through all bus lines one by one, set them as input because we try to read them, and then go through them. Basically, it does a digital read on all the bus lines, and then combine all of those into a variable called bus data. Essentially, we are just reading what data is on the bus, and then I guess we talked about this section in the previous videos. We are just printing those on the screen in our basically serial terminal. And that's it. I mean, if everything works properly, we should see that some data is set on the bus, it's saved in the A register, then the bus is cleared, and then the same data is actually put back on the bus. So with that, let's actually test the sketch and upload it to our Arduino. All right, I'm gonna upload it to our Arduino, and it should be executing right now. So at the first step, it's a value of 0. That's why we didn't actually see anything on the LEDs. But now you see that we reached a value of 1. That value 1 went to A register, and now bus cleared, and it put back again on the bus. So I guess it's executing a little bit fast. So let me just increase this timer to 2 seconds. Both of them actually. Let's do the clock also as 2 seconds. I guess that will be easier to see the LEDs when they're moving. So I'm gonna re-upload the sketch. All right, so the first step was actually writing 0 on the bus, and that's why we don't see anything, right? So now at this point, see that after the signal, because still working on the 0. So right here, we wrote 1 on the bus. A in came up, and on the rising edge of clock, it went to the A register. Now at this point, we're clearing the bus, and we do an A out, which is putting the data back from the bus into, from the A register back on the bus. And that's gonna continue. I mean, right now we have value of 2, so the same process is happening. And go to A register, clear the bus, and then put that data back onto the bus. So this way we'll be able to actually test all the values from 0 to 255 one by one, which are exchanged between our A register and bus. Now, another thing that we could do here is, let's reduce that time, because this time I want to actually show you the output, the final output, which is printed on the screen. So let's reduce those to, let's say 100 millisecond, right, for both of those timers. And I'm gonna upload that. And I'm going to actually open my serial monitor. So now you see that this is what we are actually reading at the final stage, is what is actually written on the bus. And we are kind of reading that data and printing on the screen. So you could see on the screen that data is actually started from 0, and it's going to go all the way to 255. And one by one, that data is actually exchanged between our A registers and our bus. Now, We have another function which called test register B, which is identical to test register A, except that now we'll be working with the B register. Essentially, the only difference between those two is that in B register, we obviously are working with the B signals, right? B input and B output. Now, we could be creative here and do other stuff. For example, let's say that we want to actually, the data which is written back on the bus also be written on the B register. So at this stage, when we're actually outputting data from A register, before reading the bus, so let's say output register A, before reading the bus and printing on the screen, I also wanted to actually be set at B register. So what we could do, we could basically just add this here, that the data which at this point is on the bus, after the A register is completed his job, before reading it from the bus, we want to actually set it to B register. So this way, when the data is actually put back on the bus, it will be inputted into B register. So let's increase those to probably 1 second, and so that it's not going too fast. And let's compile that. And now let's upload it. So let's see what will happen. So this get just started, and the first value is 0 again. We can't see anything on the LEDs, but so let's start with value 1 is written. Now it's go into A register, clear the bus, put it back on the bus, but this time you see that we also read it into our B register. So this way you will be able to actually test both A and B register at the same time in regard to reading data from the bus. All right, I guess that's all we have for testing our registers. In next video, we're going to look at the ALU, and we'll be testing our ALU. So see you there.